Welcome back, class. We've made it to gases and liquids now. Let's take a look at this picture. Three friends are talking about matter. Which person has the best idea? So Nate says, liquids can change to gases. Gases can change back to liquids. Arturo says, liquids can change to gases, but gases cannot change back to liquids. And Maggie says, gases can change to liquids, liquids cannot change back to gases. So who do you think is right? Let's consider what Nate says. Liquids can change to gases. We know that that is true because when you heat up some water, when you boil water, it eventually disappears. It becomes gas. It all becomes air and steam. And what happens when a gas is cooled? If you look at a cold water bottle on a hot day, you see little droplets of water on the outside of the bottle, right? Well, that's the gas turning back into liquid. So Nate might have the right idea. Let's move forward. These ice cubes are about to change. Watch the video. What questions do you have? Well, we might ask, how were the ice cubes able to melt? Will they still taste the same? What other questions might you have? What happens to the shape of water in different containers? Make a prediction. How high will the same amount of water be in each of the different containers? Draw your predictions in the left column of the data table. So we need several containers to hold water, a tray, and a measuring cup. So put the containers on a tray. So you might have a small container, a tall container, a thin container, a wide container. Fill the measuring cup with water and pour the water into the first container. Draw the container and the water level in the right column of the table below. Repeat step 2 with other containers. Use the same amount of water each time. And then draw conclusions. Compare your predictions with your results. So how are they the same? How are they different? Which container had the highest water level and why did it happen? So will you think that maybe there's a low bowl? Do you think that will have the highest level? Or if there's a thin, narrow cylinder container, will that have the highest level of water? Think about which one will have the highest level of water and why that would be the case. Would the results of the activity change if you used juice instead of water? What do you think? Now let's go over liquids. What is a liquid? Properties of liquids. Water, milk, and syrup are all liquids. A liquid is a state of matter. Matter is anything that takes up space and has mass. If you put liquids in a container, they take its shape. With no container, they would flow and spread out like a puddle. A liquid is a matter that takes the shape of its container. Look at these 3 liquids. What are some properties you could use to describe them? Remember, properties are describing words, so we could talk about the color. One is clear, one is orange, one is white. We could talk about their clarity. Are they see-through? This one is see-through. Liquids every day. Have you used liquids today? Yes, you have. Here are some ways people use liquids every day. People use water every time they brush their teeth. People also use water or milk when they cook. They might use a measuring cup to measure the volume of the liquid. Volume is the amount of space something takes up. So now that we've gone over volume and we've read what is a liquid, let's try to do some of these questions. What is property? Remember, we had these from the last class. Property is the look, feel, smell, sound, or taste of a thing. So property is a description of our matter. What is matter? Is it the amount of space something takes up? Matter that takes the shape of the container? Or anything that takes up space and has mass? It's this one. What is volume? Volume, we said, is the amount of space something takes up. And what is liquid? Liquid is the matter that takes the shape of the container. List 3 liquids in the table below, then write 2 words to describe the properties of those liquids. So 3 liquids could be water, maybe milk, and orange juice. So 2 words to describe them could be clear and maybe thin, as in it's not thick. It's not a thick liquid. Milk is white, and it might be a bit thicker. Orange juice is orange, and we could say not clear. All about gas.
This boy is using a pump to fill his bike tire with air. Gas has no shape or volume of its own, so it takes the shape of the tire. We can tell gases are there when they fill a balloon or another object. This balloon is being filled with a gas called carbon dioxide. The air we breathe in is made of a gas called oxygen. Anything that takes up space is matter. Gases spread to fill the space they are in. This bounce house was filled with air like the bike tire. All matter has mass. Gas is matter, therefore it also has mass. This blimp is filled with a gas called hydrogen.
So now that we've watched all about gas, we can answer some of these questions. A gas has no shape or, we said, volume of its own. How can you tell that air is made of matter? Because, for example, if you fill in a balloon with air, you see the balloon expanding and changing its shape. So the air is filling up the balloon. And anything that takes up space is called matter. So air is made of matter. Let's move on to this research, investigate, and communicate inquiry. Gassy bubbles. You will plan and carry out an investigation to see the gas in bubbles. Write a question you will investigate. Are bubbles filled with gas? So you'll need a tray, water, dish soap, and a straw. Plan the investigation by putting the steps in the correct order, then follow the steps to carry out the investigation. Using the straw, blow gently into the water. Add a few drops of dish soap and carefully stir with the straw. Fill the tray with enough water to cover the bottom. Record your observations. So first you put these in the right order, and then you carry them out. What happened when you blew into the straw? So draw what your tray looked like. And what made the bubbles in the water? What were they filled with? All 3 states. We have solids, liquids, and gases. You will observe an ice cube change from a solid to a liquid, and then into a gas. What will happen to an ice cube when it is left in the sun? This is something you probably already know. Place the ice cube in a plastic cup. Stretch the plastic wrap across the top of the cup and secure it with a rubber band. Then put the cup in a sunny spot in your classroom. Observe the changes to the ice cube throughout the day. Tell what happened to the ice cube throughout the day and draw your results on a separate sheet of paper. So if you remember the video we saw at the beginning with the ice cubes in the pot on the fire, use what you've learned about liquids and gases to explain how the ice cubes changed. So the ice cubes changed from solid shapes, they were the cubes, into liquids, water, which didn't have a shape. It was the shape of the container, or shape of the pot. And then they kept heating it with more heat. It turned into gas. And gradually left the pot. Clay boat. Timmy has a ball of clay. He wants to make a boat out of the clay. Which property should Timmy change to make the clay float? Should he change its length, its weight, its shape, or its color? Well, it doesn't matter what color the clay is. That won't help it float or sink. Shape, that could help, but what would help more would be weight. If it was lighter, then it would float on the water. If clay is heavy, it will sink to the bottom.
Matter, properties, and making things. The best material. How do you make or build something new? One important decision is choosing the right material. Remember that everything is made of matter. Matter is anything that takes up space. The matter from which something is made is the material. This boat is made from the best materials to go fast. Choose the best material for the purpose of what you are making. Cooks try their meals. They want to make sure the ingredients have the best taste, smell, feel, and look. The best property. Before you decide which material to use, think about its properties. A property is the way something looks, feels, smells, tastes, or sounds. Bricks, stone, and steel share the same property of strength. For example, builders use a material that has the property of being strong so that the material will last a long time. Builders think about how different materials will work in different weather. Stone, brick, and some metals can last for many years. Wood and plastic may break down when they get too wet or hot. Each material needs to be the best for where the building is located. Different materials, different purposes. Furniture makers choose different materials for different pieces of furniture. The material that is best depends on the purpose of the furniture. The purpose is how the furniture will be used. Materials need to suit the purpose of an item. Hard, sturdy materials are good for tables and desks. Tables and desks must be strong and able to hold heavy objects. The legs of a couch and bed are made from strong materials so that people can sit or lay on them. The mattress on a bed is made from soft materials. It is comfortable sleeping on a soft mattress. Some chairs are hard and some chairs are soft. Different purposes, different properties. Car designers make many decisions about materials based on their properties. They want lightweight, yet strong materials for car bodies. They want comfortable materials for car seats. The outside of a car is made from different materials than the inside. They think about whether metal or plastic is best for a car engine. They think about whether rubber or plastic is a better material for tires. They think about what material would be good for making a dashboard or a steering wheel. An engine is made from a different material than tires. New purposes for materials. People sometimes figure out how to use materials in new ways. Metal tools and other items can be used to make a sturdy lawn ornament. Old t-shirts can be sewn together to make a soft, warm quilt. The results might look surprising. However, the properties of the materials often make them perfect for their new uses. Materials can be used in new ways.
So build a model boat. Test your boat by placing it in a tray filled with water to see if it will float. Place a small eraser on the boat to see if your boat still floats. Draw your observations in the box. What materials would you use to make your boat better? So if you used paper, for example, did the paper get ruined by the water? Did it get wet? Did you use metal? And did it make it sink? Might you use a lighter material? And why did you choose different materials? A heavy rock will, if you throw it into a lake. What will the heavy rock do? Probably sink, right? Builders think about how different will work in different buildings. Materials. If you want your model boat to stay on the top of the water, you must use a base that will float. That means that will stay on top of the water. So it must be light or have little mass. Investigate how different materials have different properties by conducting a simulation. Answer the questions after you've finished. So, which of the materials broke when pulled apart? So think of some sensitive or weak materials. You have things like straw, as in wooden straw, or paper, maybe thread. These are things that might break when pulled apart. Use the table below to record how different materials were affected by different forces. So, push. What happens when you push, for example, a piece of wood or a cotton ball? Bend. What happens when you bend a pencil? What happens when you bend a nail, an iron nail? Strike. So strike means hitting. What happens when you hit a pen or you hit a plastic straw? And heat. What happens when you heat a toothpick, for example, or when you heat a piece of metal? You don't have to do these, but you can just think about them. What happened when steel was heated? When steel is heated, it probably gets hot. It might turn red. And if you melt it high enough, it might even melt. If you heat it high enough, it might melt. Car designers want strong materials for the body of a car. Is this true or false? It's true. When you make or build chairs, you always use hard materials. Also true. These are things that have to withstand a lot of weight, so they have to be strong. So that's why we use hard materials. So, circle the products that you might make with a material that is soft and flexible. Curtains, blankets, not a skateboard because you're going to stand on it and you're going to go on bumpy edges. So you're going to want the skateboard to be hard, not soft and flexible. A toy car, depending on the car, but you probably want it to be hard as well. A tabletop, that should also be hard. And a chair cushion, that can be soft and flexible. So curtains, blanket, and chair cushion should be soft and flexible. What is the best material to use for building the bridge? Explain your thinking. So do you want something that is soft and flexible, or something that is hard, not bendable, strong, like steel? So here's another research question to try. You will research different types of boats and learn about the materials that help them float. Learn more about materials used to build boats. What question will your research help you answer? It'll help you understand which types of materials float. And which ones sink. And write about what you find. What do you notice about the materials and their properties? And try to draw some conclusions. Here's another task you can try. Make a model. You will use what you have learned about different materials to plan and build a model boat. What materials will you use to build a boat that will float? So would you use string? Would you use paper? Would you use clay? Look around the classroom or the house. What materials will you need? Make a list. Draw your boat design here and explain how you will use the materials. Then build your boat and test whether your boat floats or sinks. Describe the results of your test. So did it float? Did it sink? Did it float at the beginning and then sink? Compare your boat with other ones and ask why other boats are floating better and why some are not floating as well. Draw the boat design that you think worked best and label the parts. What materials are best for building a boat? Think about the photo of the boat floating in the harbor at the beginning of the lesson. Use what you have learned to describe the materials that are best for building a boat. So for example, some materials that are not good would be paper, wood, but some that might be good could be plastic, maybe a very light type of metal, etc. You will plan and carry out an investigation to see which spoon is made of the best material. Which spoon will scoop hard ice cream the best? So I'm sure you've tried this before. Have you ever had very cold ice cream and then tried to scoop it up with a plastic spoon? What happens to the spoon sometimes? Especially when you're trying to take a big scoop, sometimes the plastic spoon breaks. And what about a wooden spoon? It's quite difficult. Although the wooden spoon is hard, it could also break, or it just doesn't go through the ice cream well enough. Metal spoons seem to work the best because they're the hardest material, so they can go through the hard ice cream. So what steps would you use to find out which spoon is best? Which material is best for scooping ice cream? Write or draw your observations.